Hi everyone, let's solve this problem maximum product subarray. In the problem statement it says we are given an integer array nums and we need to find the contiguous non-empty subarray. So which means there should be some one element present out of that subarray such that its product is the largest, right? So a subarray is the contiguous subsequence, right? So if you have seen the previous problem Kadane algorithm maximum sum subarray, which we are tracking from this Blind-75 list, like maximum subarray. So I have talked about this, like whenever we have something should be present from the input list, right? So these are like different variants of the problem using Kadane's. How do we approach it? So this will be same problem, like same pattern it will be following, but we'll see in the visualization how we'll be like trying to optimize the brute force to Kadane, and finally when this one element thing is present, how do we deal with it, right? So I'll just go in more detail because this pattern is again more useful in other problems where we can consider empty sublists, right? How do we approach about it? So we'll discuss all these, but before going into that direction, let's see the quote of the day. So it's from Steve Jobs: stay hungry, stay foolish. So never ever think that you have become smart enough that you can't learn anything, right? So always have this faith that delusional belief that there is something you are still missing in your life. The moment you learn it, it will completely change your life, right? So if you have that learning mindset, you will always be growing, right? Like don't ever believe those people who call you you're very smart or you're the smartest guy, right? Whatever, like don't ever fall into that validation trap. I remember my best friends emailing me in late night and saying that I'm foolish. Small personal story, like not foolish, they call it gawar in Hindi, right? So it means like uneducated, whatever, right? So always stay hungry, stay foolish. A lot of gyan for now. Let's go on to the problem visualization. Okay, so what is the first idea? Let's start with the first technique. First technique will be obviously the brute force. So the brute force is very easy, right? I say, okay, for all order n square subarrays, right, I will generate its product in order n time, right? For example, if I start from this position, I'll say, okay, what are all the subarrays? This, and this, right? For all these subarrays, find the max product, and this product will be found in order n. Then the total answer will be in order n cube, right? So we can write this solution is order n cube, but as we saw in previous problem, we can solve it in order n square itself, because for order n square we can get it in order 1. The product we can get it in order 1, so then it will become order n square, which is, for example, if I already know this, right, I already know the product is 2. I just need to multiply it with the 3, 2 into 3, and now 2 into 3 into minus 2. I already knew the sum product of 2 into 3, right? So that's easy, right? So if I have this, right, this is brute force. But the second technique is solving it by Kadane's kind of technique, right? So what it says is, okay, I will not write Kadane algorithm. I'll write, okay, what if cur index, right, is end of subarray, okay, end of subarray, which is, okay, I will be going from left to right, okay, like for example, I will be going from left to right. Whenever I'm here, I say, okay, if I will be the last of the answer, right? What is the maximum and the minimum product? Because the moment a next element comes, right? For example, let's say my max so far is 10 and my min is minus 20. But if the negative element might be coming in my input array, right, which is, let's say, minus 3, right? So my max, if gets multiplied with minus 3, it will become minus 30. But if it gets multiplied with the negative, right, it will become 60. So the small variation compared to Kadane's is, if I track max and min for each subarray, right, whenever I will be expanding the next subarray, I can get the answer from including it with min and max. We'll see how do we do it. That's a different story. How can we do it? But the idea is, if I keep track of max and min, right? So let's say if this is my array, okay, if I am at this index, right, if I track what is the maximum product till this point and what is the min product till this point, I can calculate max and min product here as well, right? How can I calculate it? It will be max of this current element itself, which means I broke the chain, right, as we discussed in Kadane algorithm, or I multiplied this with max, right, because it might be positive, or I multiply it with min, right? So this way I got the max when I include this in the suffixes, right? And similarly for the min, right, which is mn, how can I get it? I can get it by min of what? The same number, because it could be negative itself, and n should get multiplied with max and n should get multiplied with min again, right? So this is the idea. So I hope I was able to explain it. Again, this is one sort of pattern where we try to say, okay, like in general Kadane is, okay, what if my answer ends here? Can I calculate the answer here, right? But what about if I'll be expanding to the right, whenever the input size will be increasing? What are the possible information I want to keep with myself so that I can get the answer, right? So this is another technique, right? I guess you can go with the left answer, right answer, the other technique, which is like order n log n kind of solution, which is, okay, you'll start from middle and keep expanding till left and keep expanding till right kind of thing. But it's better to stick to these now, because those were brute forces and this is more optimized solution. Okay, let's jump to the solution now. So the first solution is, okay, let's write brute force, which is for n in, okay, for I in range of length of nums, which is, this is start, let's call it start, right? For end in range of s2 length of nums, right? My prod so far is 1, so my prod multiply equals to e, and my answer will be max of answer and prod, which is order n square solution, right? So I'll return the answer. So let's, all answer is float minus infinity, right? This is plain brute force. Let's see if it works. Okay, let's submit it. Okay, okay, I'm getting some wrong answer. Why? Product is, so I'll be starting, I've started from here, and oh no, I have to multiply it with nums of e, right? Okay, let's see. I'm waiting for, see, we got the time limit exceeded. So this was order n square solution, so we had it at order n square solution. Okay, so let's go to order n solution now, which is Kadane's algorithm, right? So for Kadane, let's comment it out. Okay, let's get rid of this part and now write Kadane. Okay, so I say, okay, my max so far, let's start with the num 0. We can keep max, min all as the first elements for now, right? If I only had single element, and my answer is nums of 0. And now if I start from this first to last elements, right? So what I can do is, okay, my max will become max of this current max and max times n, or min times n, right? And my min becomes min of min and min times n and max times n. But max has already been updated, right? So what I can do is, because in the second loop, right? So what I can do is I can keep this max in temp variable, right? And I can use it as temp. I hope you got it right, because when I'm considering the ith element, my max has already now considering the ith element, but I needed it till I minus 1, right? This is answer, and my answer will always be coming from answer or max only, right? So now we just need to return the answer. Okay, I'm getting some wrong answer here. Okay, I have num, I go here, I considered all the element, I'm picking up mx with n and mn with n, and mn with n and temp times n. Still I'm getting some wrong answer. Let's see why. My max answer is this. I need to calculate temp, which was max. Oh no, I need to have n here, right? Because n should always be in the answer. And because I'm ending my subarray, right? So yeah, let's see. Awesome, it does work. So I hope guys you like this, and remember, stay hungry, stay foolish. See you guys in next video.